Dear children, today's topic is Daniel cell. Myself, Dr. Digna Varghese. Daniel cell is a type of electrochemical cell which is invented in 1836 by the great English chemist John Frederick Daniel. John Frederick Daniel was a British chemist and a meteorologist. He first introduced the Daniel cell in the form of a copper pot filled with copper's 2-sulfide solution, in which is immersed an unglazed earthenware container filled with sulfuric acid and a zinc electrode. Okay, later he replaced sulfuric acid with the zinc sulfate solution. Daniel cell is the best example of a galvanic cell. Daniel cell converts chemical energy into electrical energy. The Daniel cell consists of two electrodes of dissimilar metals such as zinc and copper. Each electrode is in contact with a solution of its own ion. That means zinc in zinc sulfate solution and copper in copper sulfate solution. You can see here a schematic representation of Daniel cell in which there are two electrodes. One is zinc and the other one is copper. Okay, in which zinc is kept or dipped in zinc sulfate solution and copper is dipped in copper sulfate solution. These two solutions are separated by a porous partition. Okay, in galvanic cell there is a salt bridge is used, but in Daniel cell there is a porous partition is used to separate these two solutions. That means zinc sulfate and copper sulfate solutions are separated. Okay, and zinc in zinc sulfate solution, zinc metal is act as anode here and copper act as cathode here. Okay, zinc electrode is anode and copper electrode act as cathode. We know at anode there is oxidation reaction takes place. Okay, the cell reaction is like that. Anode zinc solid gives zinc 2 plus and 2 electron, that is removal of electron, that is de-electronation reaction, that is oxidation. Oxidation is loss of electrons. Okay, therefore we can say that zinc metal dissolves. Zinc metal dissolves. By this, here zinc metal is here. After oxidation, it is come into the aqueous state, into the solution phase. Okay, as zinc 2 plus. We know anode for a galvanic cell or an electrochemical cell, negative electron. Okay, so the removal of electron here, electron has negative charge, anode is also negative charge. So it is highly push the electrons to cathodic direction, in which the electrode is copper. Okay, and here copper 2 plus in the solution. Okay, this electrons accepted by the copper 2 plus and undergo reduction reaction in cathode. So the cathodic reaction is like that. Copper 2 plus reacts with electrons coming from the anode, undergo reduction reaction and form copper metal. So we can say that copper metal is plated on electrode. Okay, copper metal is plated on electrode from the solution. Okay, children. What happens to zinc? Zinc metal dissolves. What happens to copper? Copper metal is plated on copper electrode. So here the net cell reaction is like that. Zinc solid reacts with copper 2 plus gives zinc 2 plus. That means zinc dissolves copper 2 plus deposited or plated on the electrode as solid, copper solid. This is a redox reaction. By this redox reaction, the current flows, which will measured by a ammeter or voltmeter. Okay, so this is the schematic diagram of the Daniell cell, and these are the cell reactions of the Daniell cell. At anode, oxidation takes place. At cathode, reduction takes place. Net reaction is a redox reaction.